Alright, so the problem we're investigating today is a ball is thrown vertically upward at 50 meters per second. How long will the ball be in the air? Where will the ball be at 4 seconds? And is it going up or down? So we're going to start with this first part of the question. How long will the ball be in the air? So to do that, we are going to need the acceleration formula, which is acceleration equals velocity final minus velocity initial over time. And so looking at our diagram and the problem, our initial velocity is 50 meters per second. So, and we always know our acceleration is negative 9.8 meters per second squared. So we need to manipulate this problem to get time by itself because that's what we're trying to solve for. So we're going to multiply by time on both sides to get time as the acceleration equals velocity final minus velocity initial. Now we're going to divide by the acceleration to get time by itself, velocity final minus velocity initial over the acceleration. So time is going to equal velocity final, which is 0, minus 50 over the acceleration of negative 9.8. So using our unit analysis, we're going to get negative 50 meters per second and divided by negative 9.8 meters per second squared. So your meters are going to cancel out. Seconds down here is going to cancel out, and the square is going to cancel out, so you're just left with normal seconds. And negative 50 divided by negative 9.8 is going to give you 5.10 seconds. And that value is the value of time up here halfway through your trip. So to find the time of your total trip, it's going to be 5.10 multiplied by 2, and you are going to get 10.20 seconds. So 10.20 seconds is going to be the total time that the ball is in the air. So that answers the first part of our question. I'm just going to go ahead and erase this. Okay, now, to the second part of our question. It asks, where will the ball be at 4 seconds? So where will the ball be at 4 seconds? So to find that, we're going to need to use our displacement formula, which is displacement equals velocity initial times time plus 1/2 times the acceleration times the time squared. So our variable is going to be displacement because we want to know the value at 4 seconds. Our initial velocity is 50 times time is 10.20. Times the time is 4 seconds because we want to know where it is at 4 seconds. Plus 1/2 times the acceleration is negative 9.8 times the time of 4 seconds squared. So we're going to use unit analysis to get 50 meters per second and then 4 seconds divided by 4 seconds. So seconds are going to cancel, and that's going to be 200 meters. And then unit analysis for this side is going to be 0.5 times negative 9.8 meters per second squared, it's acceleration, times 16 seconds squared. So multiply those out, we're going to get 0.5 times negative 9.8 multiplied by 16. And we are going to get negative 78.4 meters. Because seconds squareds cancel out and you're just left with meters, which is what you want because we're dealing with displacement. So then that is going to be 200 minus 78.4 equals 121.6 meters. And that 121.6 meters is where you are going to be at in 4 seconds. All right. So now we erase this. 121. That answers the second part of our question. And now on to the third part of our question. We'll just leave this 121.6 over here. We're going to need it. Okay, so now our third part of our question, saying, is it going up or down? So to determine if it's going up or down, we need to find the displacement value of this right here. So we're going to use the displacement formula again. Displacement equals velocity initial times time plus 1/2 times the acceleration times the time squared. So the displacement is going to equal 50 times, we're going to use 5.10 because that is the time at this point, plus 1/2 times the acceleration of negative 9.8 times time squared 5.10 squared. Okay? So now unit analysis is going to be 50 meters per second, 5.10 seconds. Seconds is going to cancel. 50 multiplied by 5.10 is 255 meters. And then 0.5 multiplied by negative 9.8 meters per second squared because we have acceleration. 5.10 square, sorry. It's 26.01. So then, sorry, that's second squared. So second squared is going to cancel. 0.5 multiplied by negative 9.8 multiplied by 26.01 is going to give you negative 127.45. So 255 minus 127.45 meters is going to give you 127.55. So the displacement value is 127.55. And since this value that we found at 4 seconds is lower than this value that we found up here, the ball is still traveling upwards when it is at 4 seconds.